Hi, everyone. Clay Daniel here, Director of LSAT Prep for Claiborne Education with another logic game setup video for you. We're going to be looking at test 29 and the first game today. So you'll want to have that in front of you. We honor LSAT's copyright. I'm not going to read out the game in its entirety, but I'm going to address the setup more particularly. So let's take a look at that together. You will see, if you look at this and are familiar at all with the concept, that this is an in-out game. An in-out game happens whenever there are two mutually exclusive groups. That is, a player or element can only be in one of the two groups and not both. It doesn't have to be the case that there's an in-group and an out-group. There simply need to be two groups, in this case, Wednesday and Thursday, and there can't be an element, any element that's in both. So you have this mutual exclusivity, this interaction that you see in the rules where, you know, if it's here, it's not here, or if it's not here, then it must be here. That kind of conditionality is often what makes these games challenging. In this particular case, we've got a nice straightforward high yield game, and it really shows the power of this doing the setup in advance and really generating all the possibilities. We can tell that for a number of reasons. One is we have a pretty concrete idea of how many are on each day. Okay, so hard to always draw a straight line here, forgive me for that, but 3 and 3, and then there's one extra. So we're just going to leave that blank for now. In a grouping game, I always only draw a space if I'm going to fill that space. Otherwise, I kind of leave it open until I have more detail. So we know it's minimum of 3 on Wednesday, minimum of 3 on Thursday. We discover that bill 2 has to be on Thursday. And then we have a really valuable kind of rule that we rarely get on in-out games, and that's a block. So we always want to use that to its maximum potential, and we typically want to start with that. So that's a great place to start here to say, okay, excellent. 4 and 7 are a block. They're on the same day. Let's just put them on Wednesday and see what happens. Does that prompt anything in particular? Well, in fact, it does, because the last rule is invoked here by means of its contrapositive. We know if 6 is on Wednesday, then 7 is on Thursday. So by contrapositive, if 7 is not on Thursday, that is on Wednesday, then 6 must not be on Wednesday. That is on Thursday. So in this case, we have to put 6 here. The only remaining rule is that 1 and 5 are never together. So I'm going to put them in with a handle. You can certainly use slashes as well. 1/5, 5/1, either way. And that's our first setup, noting that the floater here, the free agent about whom there is no rule, that is number 3, doesn't fall into place here because we've filled in 3 spots on Wednesday. We've done the same on Thursday. So we actually don't know where 3 goes. It's a true floater in this respect. But since there are only 2 options for it, we've already narrowed down to a great extent what could possibly happen. Notice too that in terms of our decision tree thought process, if the first branch was to say that the block is on Wednesday, and we got through all the rules, we got as far as we need to go with that assumption, we have everyone in place essentially. Now we can move to the other branch of that decision tree process and say, all right, what if the block is on Thursday? Well, now that's not going to prompt the conditional rule at the end at all anymore. We have to be very careful not to make a formal logic error and say if 7 on Thursday, then 6 on Wednesday, right? That would be reading that rule backwards. But what it does do is it tells us, or it makes us think about, well, there's already 3 on Thursday. At the most, I could have 4 there. So this kind of toggling between 1 and 5 is going to be really powerful in this case. One of them has to be on Thursday, and there already are 3 there. that fills up Thursday, no matter whether it's 1 or 5 that takes that spot. Because remember, there was one extra spot beyond the 3 and 3. That has to be occupied by 1 or 5. And so this works out great. We'll put the floater number 3 in there. That should go very well. We'll put number 6 in here with the caveat that we want to make sure that doesn't violate any rule. But number 6 is only in the last rule. And I've already mentioned how we can't infer anything from there. So this is enormously powerful, very high yield, because there really are only 2 fundamental scenarios. Granted, they both have handles. In one case, we don't know where number 3 goes. But even if you spin out the permutations, I mean, what is that? Only 8 total ways that things could even happen with very little variation. You're in an outstanding position to go into the questions. That's the power of the decision tree method, where you lay out the game boards in advance so you know what you need to do with the questions. I hope you found this helpful. Check back for more similar videos from us.